Welcome to Season 8 of the NGSS ESS Working Group webinar series. And we're bringing you today a presentation called Vera Rubin Observatory Presents an NGSS Approach to Exploring Our Solar System. This webinar is being recorded, and our organizers for this event include Aida Awad. She is a NAGT past president, secretary, and treasurer. She's worn multiple hats for the organization. Ed Robeck, director of education from American Geosciences Institute, and myself, Missy Holzer, who's secretary of National Earth Science Teachers Association. And joining us today at the control box is John McDarris, who's from CERC and NAGT. Welcome, everybody. So our presenters today are Ardis Herrold. She's the education specialist from Vera Rubin Observatory, and Justine Schaen, who's an education specialist from NSF's NOIRLab. This afternoon, we'll be hearing from them, and then we'll have a little bit of time for discussion and question and answer. And we'll ask you to please do our post survey. And I understand that Justine and Ardis will also have a survey for you to complete. So just a reminder that we always want to get you to put on your calendars the next webinar that's coming up. And so the final fall webinar will be November 17th. And joining us from NSTA will be Kate Soriano, and she's their science standards specialist. And she will be sharing with us their NSTA sense-making tool and how it operates in an Earth and space science classroom. You don't want to miss that one. Join us on the 17th, and the registration is now open for that. But a reminder that we do record all of these webinars, and they are all available not only on the CERC NAGT website for our home, which is our home for registration and all, but also on the AGI YouTube channel playlist for these events, where you can actually go back over the number of years and look at all of the webinars that we've hosted in the past. So, we generally have a very active chat box during our webinars, and we want using that. Use that to ask questions, post comments, and we will be harvesting all of the questions that you have, and then at the Q&A, we'll make sure that our presenters have a chance to answer them for you. We ask that you mute while we're in this session. However, I know our presenters were going to be asking you to be active participants, and at that point, open up your mic and your cameras and all of that. Okay, so reminder, today's webinar is Vera Rubin Observatory Presents an NGSS Approach to Exploring Our Solar System. Take it away, Ardis and Justine.
Okay,
Great.
thank you.
Thank you.
So hello, everyone. I'm Ardis Herrold, and thank you so much for giving us this opportunity to spend some time with you today. I'm just going to say that before I became an education specialist here at Rubin Observatory, I was in the classroom for almost 40 years, teaching primarily Earth space sciences at the high school level. And so we're really interested to hear about your backgrounds and your experiences. So feel free to add some information about yourself in chat. And I'll turn it over to Justine to introduce herself.
Thank you, Ardis. I'm Justine Schaen, and as Missy said, I work for NSF's NOIRLab in Tucson, Arizona. I was a middle school science teacher for about 10 years, and I specifically taught Earth and space science. Part of my role right now involves working with Rubin Observatory's education team in the development of these online investigations, and we're very excited to share one of these investigations with you today. And I'm excited to get to know you all as you type about yourself in chat.
Before we begin, we wanted to go over just a few rules of the road. In our professional development workshops, we hold to a code of conduct that we always are respectful and kind of each other. Later on in this presentation, you'll be working in breakout rooms for a little bit. And we ask you to recognize that you're going to come with a variety of experiences and backgrounds, and that's perfectly good. In fact, I believe it adds strength to the ideas and the discussion. So please remember to share the stage, give everyone a chance to speak or discuss as possible. And lastly, please be present with this webinar if you're with us today, and try to keep all the distractions to the side. The goal of our workshop today is going to give you a very, very condensed view of the Rubin education programs and investigations that are available for your use. Everything we have is free. And so we're going to give you some ideas about how to access the investigations, how to unpack them, how to use the different components you might like to do. And all of this is through the lens of how we've designed these to support the next generation science standards. Now we're going to be using a document that Justine is going to share her screen and show you. It's called our links document. And on that document, you'll want to keep this link for later on in your use after the presentation. The links document has links to a lot of places for quick access on the website. And it also has a link to a document we call the Personal Implementation Plan, or PIP for short. We found that this has been really helpful in past workshops. If you take a look at that, it's sort of a sheet to guide your thoughts and your questions. And although you might not have time to print it out now, it's also available on our website. So as you take a look at the different investigations and components, it's sort of a way for you to organize your thoughts and think about what components would you use in your classroom, how would you use them, how much time would they require. And we wanted to just show this to you today in case you have some thoughts that you'd like to jot down on this document for discussion later on or in your breakout rooms. Now, in addition to the personal implementation plan, we've provided really quick links to a lot of materials and resources we're going to use today. Later on, we can talk to you about how to set up accounts on our website, but because you don't have accounts set up today, these links will give you direct access to some of the materials that we're going to be using. And you'll notice that John put the link to the links document in chat. So it's there if you want to grab it and open it up and use it during the presentation. Okay, so we're going to throw out our first poll question for you today. And that is, where do you think Rubin Observatory is located? Okay. Well, you did very, very well. It's sort of a trick question because the actual observatory is being constructed right now in Chile, but our headquarters, where Justine and I work from, is in Tucson, Arizona. So what I'm really surprised about is that nobody in this audience said that Rubin Observatory is located in space, because that's a very common idea we run across all the time when we talk to teachers about our telescope. So I'd like to give you just a very brief overview of our observatory. We are currently building it. We should have been in operation already, but there was this thing called the pandemic that put us a little bit behind. So right now we're looking at a first light probably around Valentine's Day of 2024. So we're in about the middle of Chile on a mountain peak called Cerro Pichon. The Andes Mountains are great places for observatories. One of the very best places on Earth, in fact, because of the sky quality and the climate. Our observatory is, although it's ground-based, is going to be producing a huge amount of data. And what's different about our telescope is that we are what's called a survey telescope. So instead of astronomers getting time on the telescope, we will image all of the sky available for us to see from this location every 3 to 4 nights for 10 years. And then we will make that data publicly available to everybody. We have the largest camera in the world. It's going to be an incredibly sensitive camera. the sensitivity such that you could detect a golf ball at the distance to the moon. Our investigations that we've designed cover all the common topics that you might teach, and we'll go through what those are a little bit later. But some of the things I wanted to tell you is that these investigations were designed by teachers for teachers. They were also designed in tandem with scientists who understand the fields that we're covering, and also with education researchers who have done lots of research on how students learn best with different kinds of learning approaches. So every one of the investigations you see use authentic data. And you might wonder, how are we doing that without a telescope yet? Well, we're using authentic data from other telescopes and surveys right now, and then we will substitute ours in as soon as it's available. Something that's really great about our investigations is even though they all use authentic data, you don't have to download anything. You don't have to learn any special tools, any special software queries. Everything is accessible through just a website. Our audience for our investigations are pretty much between advanced middle school and intro college level, because the sophistication level of what an intro college student might know in astronomy in a general astronomy class is pretty similar to what an advanced middle school student might know. So it's really up to you as the education professional to see how this would work and how you might want to customize it for the students in your classroom. But having said that, we have designed these to support all of the astronomy education performance expectations and DCIs that you'll have to address with NGSS as you go through these intro astronomy content. Now, all of these investigations will eventually be available in English and Spanish, as well as our webpage. I'm happy to tell you we're just a few weeks away from launching our first investigation in Spanish, and that's the first one you'll see today. We have 6 right now that are in development. One is completely done. That's called Surveying the Solar System. That's the one we'll be taking a look at today. But you can use the other 5 right now. They've been tested by more than 4,500 students and teachers from many different countries. And we've gotten a lot of input. And so what we're doing now is we're making our final revisions to that last set of investigations you see. And as we incorporate all the feedback we've been receiving, we'll release a new version of each investigation. Now, one of the other things I wanted to mention is it's often a struggle in astronomy especially, once you get away from the Earth, Sun, Moon system, to link something that's relevant to student experience. But what we have really taken pains to do is link all of these investigations to the relevant big research ideas that scientists are exploring right now. So in our solar system investigation you're going to see today, we're thinking about the same things scientists are thinking about. How would you know if a new type of object has been discovered, and how would you characterize that? All of the information that we discover about new objects that Rubin will detect in our solar system will help us understand better how our solar system forms, and also how other stars and their exoplanetary systems form.
So I'm going to play for you just a short video from Rubin Observatory about our solar system, specifically about how it is weird. One thing that's nice about this video is that it's short and it really gives a great introduction to Rubin Observatory and different science topics that it will uncover within our solar system.
You might think we know pretty much everything about our solar system. After all, when it comes to the universe, the solar system is basically our backyard. But none of us were around when it formed, so we don't really know why it looks the way it does. And now that we've found thousands of planets around other stars, our solar system is starting to seem pretty weird. In some systems, stars have planets bigger than Jupiter orbiting really close, or twice as far out as Neptune. and most have a planet between the size of Earth and Neptune, which we don't have at all. Why did our solar system end up being so weird? From computer simulations, we know that the solar system formed from a cloud of gas and dust, with its objects much closer together than they currently are. But that was during the first 500 million years of the solar system's history. So what happened in the 4 billion years after that? Evidence shows that when the solar system was young, the giant planets went through a chaotic time. Their orbits quickly and drastically expanded outward, breaking havoc and flinging asteroids and comets all over the place. Neptune especially caused chaos for asteroids, plowing into a huge collection of them called the Kuiper Belt in the outer solar system. We can't time travel to watch this, but we can study where all of the left behind asteroids and comets are and how many there are to figure out what happened and why the solar system looks the way it does. But these objects are mostly distant and tiny, which makes them incredibly difficult to find. Rubin Observatory will find more small, faint objects like comets than we've ever seen before. For the first time ever, astronomers will have millions more clues to understand this weird solar system we call home. Discover more at our website and follow us on social media. You might think we know.
So some things to keep in mind before starting the solar system investigation with your students and all the support materials that are available. Some concepts that we recommend covering first include Newton's laws, Kepler's laws, and the solar nebula theory. And you will see that there's a couple of those questions that will pop up in the solar system investigation, and students may struggle with those questions if you haven't already covered those concepts before. So the solar system investigation, it includes additional support materials, such as a pretest that can be used to help to see where your students are at, check their current understanding of the solar system. We provide you with a phenomenon activity to help build their curiosity and wonder. We'll take a look at that in just a moment. Then the investigation itself, which is the online component. And we support that with formative assessment questions. So there's a couple points in the investigation where there are natural places for you to pause, stop instruction, and just check if students are understanding the material. We have a key assessment questions document, which just helps the educator determine which questions show students overall understanding. It's an easy way to grade and assess students instead of grading all 50 questions that are on the solar system investigation. So we provide that as a resource as well. There's a summative assessment that you can give to your students. It's very short, but it covers all of the concepts that were introduced in the investigation. And finally, if you would like, you can use the pretest again as the post-test to measure any gains. So as Ardis mentioned, all of the investigations include authentic data. Specifically, the solar system investigation uses proxy data from the IAU's Minor Planet Center. And you'll see this data, how it's used within the histograms and the orbit viewer. For the solar system investigation, to start off the phenomenon, we recommend posing a driving question to your students. The driving question, Ardis kind of gave you a taste of that with the big ideas for the solar system and how this is a real problem that astronomers are going to be faced with. So Rubin Observatory is going to discover thousands of new solar system objects. How will we know if these objects are part of a group of small solar system objects that already exist, or if they are a brand new type of object? Maybe they're from another solar system. Maybe they're orbiting in a different way, and we want to know more information about this object. So this is a great question that you can pose to your students. One way that we suggest you do that is through a driving question board. But also we want to spark students' wonder and curiosity, and we want them to ask these notice and wonder questions. So to do that, we've provided this video that was on YouTube. It's a time lapse of asteroid discoveries from 1970 to 2015. I'm only going to play a small part of it right now, a little at the beginning and a little at the end, so you can get an idea of this resource. And you can maybe think of other ways that you would maybe use it in your classroom. Ooh. All right, so again, the goal of this time-lapse video is to help students start to wonder and ask different questions about the solar system. And our role as the facilitator is to help them figure out what they already know about the solar system and objects within the solar system, and help them come up with questions that they have about the objects that do exist within the solar system. What else do they need to know to help determine how we're going to classify a new object that's introduced in our solar system? So there are some NGSS design components that we considered when designing these investigations. And one of them was that we wanted them to be three-dimensional. Specifically for the solar system investigation, I have the elements here highlighted in blue, orange, and green. For blue for the science and engineering practices, orange for the disciplinary core ideas, and green for the cross-cutting concepts. And that is the same theme throughout all of our support materials for the educators. And specifically in surveying the solar system, students use models and analyze graphical data to identify similarities and differences between the orbital properties of groups of small solar system objects. Then use patterns in the data to classify newly discovered objects. And I'm going to take a moment right now to uncover the first part of the investigation with you, because in a little bit, we're going to have you dive into the investigation and go through it yourselves, but we're going to have you skip the first part. The first part seems to be the longest part for people to get through. So I'm going to try to work us through that as fast as possible so that I can give you enough time to explore it on your own. So this is what the investigation looks like when you open it up, and Ardis will walk you through that in just a moment. Right now I'm putting in the educator passphrase, which helps me to navigate through the pages without putting in answers. Students, on the other hand, won't have that power, and they'll have to type their answers as they go. So this is just a quick example of what the Surveying the Solar System investigation is going to look like when you open this up with your students. The first page just provides background on Rubin Observatory and covers the big ideas that Rubin Observatory will uncover related to the solar system. There are essential questions on this page. It is not meant for students to answer these questions, just reading them to understand the purpose of the investigation. Page 2, they're actually trying to find an object moving similar to how scientists will do that with Rubin's data that comes in, and record the time difference between the object moving. On page 3, they are introduced to the concept of semi-major axis. And this is really important because they're going to be working with data in a few pages, and they need to understand what semi-major axis means. So just to cover that with everyone, semi-major axis is the distance from the sun to the planet, the average distance from the sun to the planet, and Earth is like the reference point of being 1, and the unit is astronomical units. Then we have this great gift to highlight eccentricity. The eccentricity of a planet is how elliptical or how oval shaped the planet's orbit is going around the sun. And for Earth has an eccentricity of almost, I think, 0. Am I correct on that, Ardis? Yeah, about
Pretty
0.
close.
Yeah, relatively circular. And then the closer to 1 it gets, the more oval shaped the planet's orbit is. Inclination, you can think of Earth having an inclination of 0, and anything for the degrees less than 90, that means the planet is traveling in the same direction as Earth going around the sun. If its inclination is greater than 90, that means it's orbiting in the opposite direction to Earth going around the sun. And again, this is another great gift that students can use to understand this idea. Students will have the ability to go back to these slides or these pages in the investigation at any point if they need a reminder for what these concepts are. The next page just covers the 4 main groups of small solar system objects. The only information it reveals to the students is where these objects are located in the solar system. And this is going to, again, be useful information as they start to analyze data on the next slide. So on page 7 here, they're starting to look at these histograms. They start with NEOs, near Earth objects, and they click on these tabs here to navigate the different orbital properties. So they need to read these histograms and determine the size of the orbit, their eccentricity, and their inclinations. As they fill in these orbital properties, they also get organized on a table for them on these pages. Mine's filled out because I did this beforehand, and they do that again on page 8. In a few moments, you will be starting on page 9 and doing it from a perspective of a student. So you're going to go through and read this histogram, fill out the orbital properties, and go through the investigation up until page 17. And if you have time, we would like to challenge you to try to get to page 20. That would be the ultimate goal there. So what I just showed you with the histograms, students are analyzing, interpreting data. They're doing that to understand the high school and middle school DCI of Earth and the solar system, and they're using patterns within this data to do that. What you will also see, I did not give you a preview of that, but as you continue on in the investigation, you're going to see that students are developing and using models with our orbit viewer with the same DCI and the same cross-cutting concept. And I believe Ardis is going to take over from here to unpack a few more features that you should notice as you're navigating through the investigation.
Right, thanks, Justine. I've put in chat, if you've noticed, a direct link to the investigation. And also I've put into chat, a couple of you have been asking about the password, the passphrase, what it is, because you saw it on Justine's screen. So we'll be talking about that too. So I'm going to take just a minute to get to the investigation page that you should see here. And the passphrase, which I put in chat, is a 3, and then the word educator spelled out, capital M, OD 3. So we've replaced the E's with the number 3. And this is a way that will enable you to skip through any page of the investigation without having to answer the questions. Now, we don't want students to have that. So it's always written in a teacher guide, which students don't tend to look at. But we've designed these investigations in such a way that students cannot go through the investigation without answering every single question. So they're forced to do it in order. And I want to just introduce to you a few things that you might see on my screen here that will be helpful to you. In the upper left corner, we have a table of contents that will show you a progress bar and will also show you every page of the investigation, including the one at the very end, which is your answer sheet. In the other corner, the upper right corner, you can see there's a toggle switch that will take you between the English and the Spanish version of the investigation. It's already started in Spanish, not quite there yet, but we're very, very close. And across the top of the investigation, as you move through it, you'll see a progress bar. Right now, it's not filled out, but as you go along in the investigation, that will give you an idea of how far you are in the investigation. And these little icons that you might see at a couple different places along the progress bar are our checkpoints. Those are the places that Justine mentioned to you earlier, are places where you can stop and use our formative assessment materials to do some check for understandings and also some redirects of teaching. So what I'd like to do right now is I'm going to stop sharing my screen in a moment. We're going to show you just a few more slides and then get you into breakout rooms. So Justine, we can go then up to the next slide, please.
Mm-hmm.
Okay, so you're going to be in breakout rooms for about 10 minutes. Sorry, we can't make it any longer, but we have very limited time.
Mm-hmm.
Let us know right away if you need help. We're going to put you in groups of 4. So just send a message to us in chat if you need help with anything, and we'll come to your breakout room to help you out. Try to work together as a team. Now, you're not going to have a lot of time, so it's not necessary that you read all the words out loud to each other. But what we'd like you to do is to complete at least the drop-down menus for answers, but not the open-ended questions, because that will just take way too long. And if you are done early, you're welcome to go ahead, as Justine mentioned, at least through page 20 of the investigation. But our goal is to get you to work through to page 16, so we can talk about that when you come back.
That's great. So we can open up the breakout rooms. You'll be in there again for about 10 minutes. And just to repeat what Ardis said, you do not have to put in any complete answers. We just want you to get an idea for the investigation and the different tools that are available to help your students make sense of the solar system and objects that exist in the solar system. All right, welcome back. I know that was a really short amount of time and our investigation has so much to offer. But we hope that you took away at least one new tool or idea that you can use in your practice. If you were to continue on to the next section of the investigation, the final section, we have built-in opportunities for students to make connections with the learning and provide their own experiences. Specifically in this investigation for section 3, students are introduced to a new group of objects, and they don't fit into any of the other 4 groups that they've already learned about. Now, this is real data that they're working with, and they have to come up with their own name for this group of objects based upon analyzing data about its orbital properties. And again, they work with histograms and an orbit viewer to do this. And to build the connections and to connect it with their own experiences, we have them come up with a way to communicate this information and to share their new discovery with the public and try to create a large audience. And some ways that teachers have mentioned that they would do this in their classroom is have students create short videos or talk about social media strategies that you would use. Students have brought up TikTok videos before to create awareness. So connecting with like the world that they live in currently and social media and the power of it to increase awareness of discoveries. Again, I want to point out that these checkpoints are opportunities for general formative assessment, but also opportunities to connect back to the phenomenon. We specifically have provided educators with questions that build upon what students understand about the phenomenon and even this time-lapse video. So this time-lapse video of the asteroids within our solar system, it stops at Jupiter. It doesn't go on to the TNOs or the comets. And so we asked students at one of the checkpoints to create a model, to create their own sketches in their notebooks of what the solar system or what this time-lapse video could look like. If it were to include TNOs and comets, we asked them prediction questions as well. Predict how this time-lapse video is going to look different in 2030 with Rubin Observatory's new data. And additionally, I just wanted to mention again, we do have a summative assessment and a scoring guide. The scoring guide breaks apart each of the dimensions, and we provide for you possible student responses just to help you effectively grade their summative assessment. And we break it down into 4 levels. Now, Ardis.
Thanks, Justine. These assessments and such that Justine's been talking about, I want to mention that they are downloadable and customizable for you. So we have a Word version and also a PDF. The teacher guide is a very extensive teacher guide, and we recognize that sometimes people are put into classes teaching where they don't have a strong content background, or maybe you know astronomy, but you've never really taught it as a course before. So we've anticipated the kinds of things that might come up in your students and in your discussions. We've provided a lot of that information in the teacher guide, as well as a 15-minute science video from a science expert in the field and their presentation materials, and much more. So we encourage you to check it out when you have time. I'd like to just mention that on the main website, and I'll put the link to the main website in chat right now, we have more materials that you can build off of, general information on Vera Rubin. One thing I'd like to point out in particular is a feature called Rubin Voices, where we feature profiles of different scientists with a lot of diverse backgrounds, their stories, a little audio snippet of their own voice, and a set of trading cards that you can print out for your students with these scientists and all kinds of other people too, engineers featured in Rubin Voices, as well as the other kind of things you'd expect on an observatory website. Lots of pretty pictures, slideshows, links to videos on our YouTube channel as well. We also have a community of practice. So we have it in 2 different versions. If you are a social media user, you can search for us and join us today at Rubin Observatory Educators. But we recognize some of you do not use social media. And for you, we've created an email discussion list. All you need to do is click the checkbox on your workshop evaluation, and we will add you to that list within a day, promise. Okay. Now, one thing you won't see on the new website without creating an account are any of these assessments that Justine has mentioned, because we don't want to give students access to those assessments and their answer keys and their scoring guides. So if you would like to access all those assessments, sign up for an account. You can do it 3 different ways: with Facebook, with Google, or just to create an account on our website. And if you need any help, please feel free to contact us. All right, we can go on. And we are required by the National Science Foundation, who funds us, to collect metrics for our workshops that we do. So please, if you could, take just a few minutes as we're wrapping up our discussion today and fill out our workshop evaluation that you see here on the screen. And Justine has also put a link into chat. Remember that links document we gave you earlier. It has a way to contact Justine or I, and a lot of other direct links to the other investigations we didn't have time to share with you. We thank you for your patience today, because we tried to do in 45 minutes what we usually would do in 5 hours. So hopefully you got interested enough where you'll come back and take a little bit more time to explore, or come to one of our other workshops, and we'll be happy to help you out. Soon, within a month, we're going to be releasing our next new investigation on Hubble's law called Expanding Universe. And I think that's all I need to say. So thank you, and we'll open it up to questions or discussion.
Wow, that was terrific. Thank you so much, Ardis and Justine. We do have some questions. Ed, can I pass it on to you to grab those questions? I think there was one in the chat box, and then I think we have a series of questions as well. We have time for about 3 or 4 questions.
Absolutely, happy to. That was really wonderful. Thank you so much for that. One of the questions is from the chat box. I have, let's see, trying to work on the wording, digital platforms for students using Chromebooks.
Yes, I read that question. I'll just chime in. So the question is, how can I distribute this investigation to my students? What's an easy way to do it? And they were asking about Google Classroom. You can certainly do it through Google Classroom. You can give them the link to the investigation, just that direct link, and they can access the investigation that way. Of course, they can also go to the website as well. But yeah, it works on any of your LMS, any system that you might have for your classroom.
Terrific, thank you so much. One of the questions that we saw was about the assessments. Can you describe the approach that's taken to assessment? Is there a general approach that you take you can describe?
I think our assessments, we wanted to assess everything. So we started with a pre and a post test. So that's one of them. Super short and sweet. It's only 10 questions, but teachers have the ability to add more questions to it as well. But then we also have the formative assessment questions that occur during the investigation, where the students can make sure that their students are confident enough to continue on to the next phase of the investigation, and that nobody gets lost along the way. Because as you've noticed, as you go through the investigation, you don't necessarily know if you're right or wrong. So we want the teachers to stop the learning and make sure that everybody's on the same page before continuing on. And then, yeah, finally, we have the summative assessment, which we did want to have the 3-dimensional elements as well. And those are highlighted within that summative assessment, which I believe you have access to on the links document as well. I'm not sure if there was a more specific question, or if Ardis has something that she wants to add to the assessments.
No, I think for the time we have, that's probably a good enough answer.
Okay.
One thing I want to throw in, I've seen a number of you ask, how can you know about our next workshops? How can you get added to our contact info? There's a little checkbox on the evaluation that you see on your screen. Just click it and we will add you to what you would like to be added to, whether that's our mailing list or just notifying of workshops. And we definitely will be back in touch with you.
Great. I see a couple of questions that popped up in the chat, and I want to give those priority. One was, is there any way to level these by grade level? And then there was another one that I'll go ahead and ask, and you can take them in any sequence. How long are these investigations likely to remain available?
Justine, take the grade level one. I'm writing a response in chat, and I'll take the other question, okay?
Yeah, sure. So for grade level in the assessments in particular, just to go back to that, the key questions assessment, maybe let me share my screen and show you how we did break down the DCIs for the key questions. Give me 1 second. So this is an example of our key questions document, and you can see where it's like an easy way to check, okay, is this a middle school or high school DCI? So that's the easiest way to do it. I would recommend using the key assessment questions document, and we have these for each of the investigations. And in our third column here, we show where students' total understanding of that, or overall understanding, I guess is a better word, of that concept would be in the investigation. So for example, for the high school DCI for Earth and the solar system, forces in motion and interactions, we recommend assessing questions 31, 32, 52, and 53.
Okay, I'm going to take the question about how long will investigations remain available and how can you find them? We gave you on the links document links to 2 different websites. Our new website only has 1 investigation on it right now because it's in the final version. Our old website that Justine is showing you right now, called the Rubin Education Testing website, has all 6 investigations, including all of the support materials. And if you would like to see the assessments on that, just to the left of where that link was on the links document is the password that you, the email and password you use to access the assessments. It's the same for everybody. This was the site we used for testing these investigations. And so you'll be able to add, use those at any time. But as we revise these, we will move those investigations over to our new website. So right now, if you're going to use the solar system one, use it on the new website. That's the one that is the most updated. Last thing I'll say is, not only will we keep these available for at least 10 years, but we will continuously improve them, and we will back them with real live human support like Justine and I. So take that for what it's worth.
Thank you so much. And thank you both for this wonderful webinar. And Missy, I'm going to pass back to you to bring us to closure.
Okay, well, thank you very much, Ardis and Justine. That was absolutely terrific. And just reminder to everybody that's still with us that this has been recorded and you will have access to it. So you can go back to it. If there was that little nugget that you missed and you were hoping you caught it, you can go back and watch the archive. Thanks so much. On the reminder about November 17th, get it on your calendar. Kate Soriano is going to be here from NSTA, and she'll be sharing her sense-making tool in an earth science context. You don't want to miss that. She's a fellow geologist, and so she speaks our language. Just remind you that the entire archive of our 8 years of webinars is available on the AGI playlist. And this webinar was made possible from your friends at, one more thing. Not only did you have an evaluation from our presenting team, but we also would like you to complete an evaluation. And there is the link right there, nagt.org/260499. And this webinar is part of the NGSS ESS working group team effort. It includes Aida Awad from NAGT, and the NAGT team offers webinars consistently on a almost weekly basis. And so make sure you visit their website and learn a little bit more about their webinar series and all they have to offer. It's also hosted by NESTA, National Earth Science Teachers Association, who is a K-12 organization, and we have a prominence on social media. We have a quarterly journal, and we have e-news with all kinds of timely materials for you. Ed, real quick.
And I'll leave it there with AGI being a federation of member societies with all things related to earth science. Many different professional organizations belong to AGI, and we do a lot of things on their behalf and on your behalf. Please visit our website, and especially with respect to Earth Science Week, which we just completed last week on sustainability. So thanks all very much for being here.
Okay, and with that, we are going to close the webinar. And again, thank you very much, everyone, for joining us today. And a special thanks to Justine and Ardis, and a special thanks also to John for steering us in the background there. Goodbye, everybody.
Thank you.
Goodbye.
Great job.